Hello everyone and welcome to the solutions video for Codeforces round Technocup 2022 Div 1 plus 2 778. I said it in the correct order. So I'm going to be explaining the solutions for A to D, and with that said, let's begin. So problem A. Don't mind the background noise if there is any. I can't do anything about it. So due to the timing of the contest. So anyways, so in the first problem, we have n pieces of a cake, all right, and they are of different sizes. What we want to do is we want to maximize the adjacent sum. So a1 plus a2, a2 plus a3, an minus 1 plus an. We want the maximum of them to be highest. And when does that happen? Obviously when the maximum element and the second largest element are adjacent, right? And what operation we are allowed to do is only once, not only once, at most once. Take, but it's the same thing, because one operation in vain would be to select any one length subarray and reverse it, which will result in the same array. So now what we want, what we are allowed to do is reverse any subarray. So let's say this is the max element here. There are some elements. This is the max 2, which is the second max element, and there are some values. So it will always be like this. So what I can do is select this and reverse it, and then I will have a max 2 and a max adjacent, and I will get the highest value. And so we just need the first two highest values, and the sum is the solution. I mean the answer. You can do it in linear time obviously, but it doesn't really matter, so I did it after sorting. Okay, with that said, let's go to the second problem, prefix removals. So in this problem we are given a string. So let's say a b c d e c sorry a c b d e. So what we can do is take the maximum x, right? Yeah, so take the maximum length of the prefix and let the length of the prefix be x. So take the maximum prefix which occurs somewhere elsewhere in the string. So let's say if I were to take ab, then or hmm, let's say, okay, this was a bad example. So if I have a b c e d a b d c e f, so notice that ab occurs here as well. So we'll take this prefix of length 2 and remove it, and now we're left with this, and I keep doing this until I cannot do it any longer, and then I need to tell what is the final string. Okay, so how can you figure out what will be the final state? So notice that for any prefix, right, whatever the prefix is, right, so let's say it's like abc d or something like that, for it to occur somewhere else in the string as well, which is not a prefix obviously, it can intersect but it cannot overlap. Now for it to occur somewhere else, this a needs to be present somewhere else, b needs to be present somewhere else as well, and so on and so forth. So that means that so if a b and c are present somewhere, they will get removed. But matter of the fact is that let's say it is abcd and then it was abcd like this, so this gets removed entirely. However, even if it was like a something something b c and d, even then they do get removed. So even though the number of operations taken is longer, the final state is the same, which is this part of the array, or you can say this prefix being removed. So it really does not matter in which way the prefix is being removed. All we have to consider is that if a or the first character occurs somewhere else in the string, then it will get removed. And so we can iterate from left to right and see, okay, if is the first character occurring somewhere else? If yes, So let's take this for example here. Then I remove this and I move off to the next character. B also occurs somewhere, so I remove B as well. Then C, uh, okay, so where does C occurs? C occurs here, so C can also get removed. Then E also occurs and D also occurs. However, now we are again at A, but there are no more A's left, and so the prefix will never match with anything, because if A does not match, AB will never match, right? And so the remaining string would be the suffix from where the first mismatch occurs. So to do that, obviously you can have a map of what am I saying? So you can just store all the frequencies and iterate from left to right. Keep decrementing the frequency. Once some character's frequency is 1, that means the operation needs to stop here, because now it does not have any corresponding pairing for which it can match the prefix. So that's what I did. Stored the frequency of every character and then iterated from left to right, and whatever the current character is, if its frequency is 1, that means there is no more character uh, later on in the string, so I break out of the string. Otherwise I remove it, and hence its frequency goes down. And then so like I said, this process ends at I, right? So the remaining string is from I to n minus 1, and so I just print the remaining string over here. Okay, this was also simple. ABC were actually very simple. That is why the explanation is going to be very short. Okay, so problem C. So here we have a cake which has initial weight x. Now this can get broken down into two weights, x and x by 2 and x by 2. So one is floor, one is ceiling. It is just because if it is 4, it gets divided into 2. If it is 5, it gets divided into 2 and 3, right? Because odd numbers do not equally divide. One of them has to be ceiling, and one of them has to be the floor division when divided by 2. And so this is the operation that happens, and yeah, Alice does this operation as many times as she wants, and then she ends up with n pieces of cake. And obviously for doing this operation, size or x needs to be greater than 1, otherwise we cannot divide. So so we end up with n pieces of cake, and we just want to tell if it is a valid configuration. That is, if this array was obtained via a process of these operations or not, because it could be like 1 and 7. 1 and 7 cannot be obtained. However, 1 and 2 can be obtained, because 3 will get split into 1 and 2. However, 8 will get split into 4 and 4, not 1 and 7. So that's what we want to tell. And so notice that the sum of all these elements is the initial value of the weight of the cake. So let's say x is the total sum. Now this will get distributed into 2, and those two values are fixed, right? So that happens, and then they also get broken down if they were not present in the final array, right? So we are trying to visualize what the process for getting that array must have been like. So we have the total sum of x, the total weight of x, which is the sum of the array. Now Alice could break it into x by 2 and x by 2, right? And now if let's say one of the elements was this, then that means this was not broken down further. However, this was broken down further into 2 elements. And then we have something like, let's say p and q. Let's say q existed in the array, that means Alice stopped here but divided p further. So it keeps on happening like this, and so we can just do this same simulation and make sure that in the end all the elements of the array were covered. So for example, let's take 1 2 4 and 7, right? The total sum is 14. So 14 will get divided into 7 and 7. Notice that 7 existed in the array. So for one 7 she must have stopped. For the other she must have divided. 4 and 3, 4 was present, and then 3 was divided again like this, right? However, now now let's consider something else. Let's say it was 2 2 to 4 7. So it was like so 2 2 4 7. Please don't mind the background noise. So it is 15, right? It gets divided into 7 and 8. Okay, this is a pretty clear division. I'm not able to come up with an example on the spot, but how will we figure out if this configuration was invalid? Okay, let's just take an invalid configuration like 7 and 1. Okay, so 8 comes up with 4 and 4. Now notice that this 4 is not present in the array, so that means she must have divided it somewhere. 2 2, right? And then 1 1 1 1. Now in this process, notice that once we reach 1 here, this will get removed, right? I mean, we have covered this, so let's remove it. And now this one is not present in the array. In fact, it is smaller than the smallest element in the array. And if that ever happens, that means that this element is going to go unused, because this obviously cannot grow back into something. We are never, combining any two pieces of cake. We are only dividing them. So since it can only become smaller, and it is smaller than the smallest, that means it is an invalid configuration. Let me show you the implementation. Okay, so the implementation is like this. Don't mind this. I take in the input and then I calculate the frequency of the array, because I need to keep track of which elements have been covered, right? And now I make a multiset, because it will help me do this simulation much easily. Okay, why am I lagging? There any issue here? Doesn't seem like. So, and to it I add the total sum of the elements, which is accumulate function. Now I take out the first element, I erase it from the multiset, right? So initially I had 8 and I removed it. Okay, let me just delete it and do it again. So initially I had 8 and I removed it, right? So after I remove it, I end up with 4 and 4. So I end up with 2 4s. Okay, and then, like I said, if this element is smaller than the smallest element possible, the smallest element is just the first pair in the map, right? Because map is sorted by key. So if that is smaller than the smallest possible, then obviously break. Otherwise, if it exists, right, it could be that it does not exist, right? So like in 7.1, 4 does not exist here, but after breaking down further, it becomes 1. Okay, this is lagging. I'm gonna have to pause and then come back. Okay, let's try again. So where were we? Right, we were simulating this. So yeah, now 4 can become further down the line 1, which is an element which exists here. So that is why we don't immediately break, right? If it doesn't exist. If it does exist, obviously we decrease its frequency, and if the frequency of that element becomes 0, because they can be duplicates, right? That's why I'm managing it via map. I remove it, simple stuff. However, if that is not the case, then I break it, right? Like I'm breaking 2. The way I'm breaking 2, 4 into 2 is, I get one is the ceiling, one is the floor, and other is the ceiling, and then I add them into the set. If in the end there was any element left in the map, then it is not a valid configuration. Otherwise it is. Okay, so that was C. How is system testing going? Not started yet. whatever. So problem D now. Okay, so in this problem, we are given that we have to use n ingredients, and the ratio in the final portion has to be r1, r2, rn. But we don't know the values r, but we know some other values. That is, let's say we have four elements, right? Four ingredients, right? If that is the case, then we know that maybe what is the ratio of volume of ingredients used between 1 and 2, and maybe 3 and 2, and maybe 4 and 2. Okay, so we are given just enough to form a unique configuration of these values r's, and then what I want to do is find the sum of the volumes, right, where every volume is integer. So basically, let's say one element is so there, let's say there are three elements. Okay, so if there are three elements and the ratios given is like this. Okay, what is this? So if the ratio given is like 1 is to 2, what's going on? And 3 is to 4. Okay, in that case, what happens is, let's say this was 1 units, then that means this would be 2 units, right? And if this was 2 units, okay, is it my mouse? uh, then this would be 2 by 3 times 4 units, right? Okay, this just seemed like my problem with my mouse. So I'll be back again. All right, I have switched my mouse battery, so let's continue. Okay, so here that means the volume for this would be 2 by 3 times 4, which is a fraction, right? So that is 8 by 3. So we'll have to multiply everything by 3 to get minimum quantity where everything is a positive integer. So that is the question, and now what we want to do is tell the sum of all these values. So how can we do that? Well, let's so first of all, we are given n minus 1. What is this? Relations, right? The ratios, and that obviously forms a tree. Only then we will have enough information. So let's say it is like this. Let's say it is 2 is to 3, 4 is to 2, 5 is to 7, right? So we can just give it value 1. Okay, I'm going to use a different color here. So we can just give it a value 1. That would mean this is 3 by 2. That would mean this is 3 by 8 multiplied by 2, right? And that would mean this is equals to 3 by 10 multiplied by 7. Okay, so we have all these values, and then we can take the LCM of all these denominators, right? So 2, 8 and 10, the LCM would be what is it? 8 times 5, 40, right? So if you multiply everything by 40, we will get the minimum positive integer values for all the volumes. That is all we have to do. But the major issue here is that these values will become very big. So how can we deal with this? The way I did is I maintained what is the LCM of all the denominators I'm gonna make, right? So all the denominators I make, I will get their LCM, and I'm also calculating all these values, all these fractions. So I can get this value modulo. Why is it happening today? So I can get this value modulo m, right? And that would be an integer. So I store all the individual values, right? So the way I'm doing this is I'm obviously doing a DFS. I give some value, initially 1, And then from there on, I derive what will be the fraction value for everything else. And for every fraction, I'm calculating its value modulo m, so that is an integer. Now I'm going to add all these values. Now this is not the correct answer because it is obviously including fractions. What I need to do is multiply this entire value with the LCM of all the denominators. And that is why I'm using another variable called base, which will store the LCM of all the values. Okay, so with that said, let me show you the implementation. There was really not much to tell about the logic. The logic is like I explained, you push some value as one, right? Or you can put other, but then that would be not minimum, right? So give some value one, and then you just derive the remaining values because it always forms a tree, because they say that information is enough, so it must form a tree. Uh, so because it forms a tree, I'm able to derive the fractional value for everything. And now the final answer is obviously 1 plus 3 by 2 plus 6 by 8 and so on, right? And so I'm storing all these values in mod so that I can just simply add them as integers. And once I have that value, let's say x, I need to multiply it by the LCM of all the denominators I had, so that this becomes a sum of all the values where everything was a positive integer, right? And so I need this LCM, and the way I'm getting this LCM is just by maintaining it. I'll show you. So I made some uh, syntax sugar structs for. So one more thing I needed was the prime factorization of every number. So for that I use linear sieve. You can check this from CP algorithms. It gives me a LP which tells me the lowest prime number dividing I, and so using that I can get the prime factor for it. So like if I am given 8, or let's say 10, then the LP 10 would be 2. So I add to my prime factorization 2, and then and divide it by 2, so I get 5, and then that would be 5 again, so 2 comma 5 will be the answer. Then I have a simple fraction which stores you know a fully non-divisible fraction. It cannot be further divided or simplified. Yes, that was the term. Another helper function, and then this base represents the LCM. Now the way I'm storing this LCM, because it is very big, is as a prime factorization. So prime number and its frequency, and then I have a number. This number is just numerator, denominator, and a value. So numerator is a prime factorization, denominator is a prime factorization, and value is just the modular value that I was mentioning here. So I have multiplication and division. Multiplication and division, how they happen is, for the value I can just do modular multiplication. Similarly with division, multiply with mod inverse. But for the numerator and denominator, what I do is I prime factorize, and then if it is present in denominator, I remove from there. Otherwise I add to numerator. Similarly do that for denominator. And also so notice that if there are two numbers whose prime factorizations is like this. So why is this lagging? Laptop, what are you doing? So this is fun. Okay, so let's say one number has prime factorization like this, 3, and another has like this. So their LCM would obviously be 2 to the power, what is the maximum power, 2, and 3 to the power, what is the maximum power, 4. And just a second. And that is how I'm maintaining what is the LCM of all the denominators. Make this. Okay. uh what's happening? All right, So now that it is not hanging anymore, yeah, so that's how I'm storing the, what is it called, yeah, the LCM of all the denominators just by taking the maximum of that prime factor's frequency. And now the way I'm doing DFS to derive the numbers. So like I mentioned, I was adding all the modular values to one value, that is total. And I swear, so many noise, so much noise. Okay, so anyways, this is my graph. This is the number that I'll be using, and U and V. So this is just DFS. So I go through all the values and I add the modular values. Like I mentioned, I will add them and then multiply with the LCM. So that's what I'm doing here, and then I'm going through every next vertex that I want to visit, and I'm multiplying and dividing by P and Q. So that's how you provide, right? So if it is 1, what will be the ratio here? That would be 1 divided by 2 multiplied by 3. That's how math works. So that's what I'm doing, and then I'm doing a DFS, and then I'm undoing that effect because I want to gain back this 3 by 2 value, because this would be overridden to be something else. The reason I cannot copy this is because that would become on square, more than on square actually. So that is the main thing. So anyways, let's go through the flow once. Take input, and for every for every edge I'm storing the fraction. Obviously it is different, reverse in different directions, and then that's the initial value. Num is initialized as 1, as you can see here, and then I'm doing the DFS and I'm calculating the value of that LCM which was stored in my base, right? So I calculate its modular value and then I multiply it with my total value, which was the sum of the fractions, and then I just print it. There can be other implementations as well. I think mine was rather clean. And with that said, okay, yes, this video was a little scuffed, but I did not anticipate that. I really did not think it would happen. I'm sorry about that. But the problems were actually pretty simple. So they did not require that in-depth explanation. And D was also just implementation. So not a problem as far as I can tell. Hopefully. If you have any problems, ask in the comments or join my Discord and ping me there. I am trying to help more and more people there now that I'm actually practicing CP sometimes. And with that said, uh, I'll see you guys next time. Make sure to subscribe, and bye.